transform, properties, inverse Fourier transform, solving differential equation, and how to apply Fourier transform to analyze the electric circuit. Okay. Next, we'll start today inverse Laplace transform. In the next class, we will complete remaining everything because very short period of time. I should cover all the topics in all the units, 4, 5. Inverse Laplace transform. For solving inverse Laplace transform, basic Laplace transform you should remember. L of t, what is Laplace transform? U of t, what is Laplace transform? E power minus at, del of t, Laplace transform 1. U of t, Laplace transform 1 by s. E power minus at ut, Laplace transform 1 divided by s plus a, but real part of s is greater than minus a. Similarly, minus e power minus at u of minus t, Laplace transform 1 divided by s plus a, but real part of s is less than minus a. Because while finding the inverse Laplace transform, they will specify the ROC also. For this particular ROC condition, what is x of t? So that time you have to do carefully. So apart from this, cos omega t ut available, sin omega t ut, e power minus at cos omega t ut, or e power minus at sin omega t ut. Almost 6 to 8 formulas only available. We have to divide the given x of s or h of s term into any one of this format, either 1 by s or 1 by s plus a, or cos omega naught t ut, sin omega naught t ut, any one of the Laplace transform formula. Example 1. Find inverse Laplace transform of x of s equal to s divided by s square plus 5s plus s. Find inverse Laplace transform. There is no ROC condition given, so don't worry about this e power minus at u of minus t and all. If ROC is not provided in the questions, you always assume unilateral Laplace transform. That is, don't go for this u of minus t term and all. Assume all your result in terms of causal signal only. Okay. If region of convergence specified, then we should use the appropriate formula. Greater than a pole, we have to write in terms of causal signal answer. Less than a pole, then we have to use this answer in terms of non-causal signal. Between two poles, then two answer we should write. Okay. So I'll tell you how to write the answer. So in first example, nothing is mentioned. Find inverse Laplace transform for the given x of s. Factorize this equation. S plus 2, s plus 3, correct? Multiplication of two number. 2 times of 3, 6. 2 plus 3, 5. Now do the partial fractional method. S divided by s plus 2, s plus 3. A divided by s plus 2 plus b divided by s plus 3. Okay. Partial fractional method. I hope you are good at partial fractional method. In Fourier transform itself, we have used different type of partial fractional. Simple pole and a pole more than one time computation, how to find your factor. So everything we discussed in the Fourier transform problem itself. Please mute your audio. Roll number L48. L48, mute your audio, please. Some students, please call him and inform him. So S equal to A S plus 3 plus B into S plus 2. Okay. Substitute S equal to minus 3. L49 or 50, please call him and inform him to meet the. Okay. Okay, partial fraction, I think no need to spend much time. So you know already how to solve this partial fraction. Even in Fourier transform, we discussed. Suppose S plus 2 square is there, then how to factorize? Or S plus 2 cube is there, then how to factorize? So please recall the Fourier transform lectures. You will get the clear idea how to factorize and how to find the values of ABC. So this is simple two poles. So S equal to minus 3. Minus 3 equal to 0 plus B minus 1. Okay. So minus 3 equal to minus B. B equal to 3. Right? Next, substitute S equal to minus 2 in equation 1. So minus 2 equal to A. 3 minus 2 plus 1. B will be cancelled. So A equal to minus 2. Okay. So two factors, A minus 2, B 3. Now rewrite your X of S. X of S equal to minus 2 divided by S plus 2. 3 divided by S plus 3. So inverse Laplace transform finding is very simple, but you should remember the 8 formulas. Up to e power minus at cos omega t ut, e power minus at sin omega t ut. Okay. The problem is very simple. Factorize and find the value for A, B, C and so on. And finally substitute in the formula. ROC is not mentioned. So we know already e power minus at u of t. Laplace transform result is 1 divided by S plus A. So minus 2 is constant here. 1 divided by S plus 2. E power minus 2t dot u of t. Plus 3 is constant here. 1 divided by S plus 3. Inverse Laplace transform e power minus 3t dot u of t. So and hence the inverse Laplace transform is computed. Similarly, whatever may be the problem given, your duty is convert that particular problem in terms of any one of the formula of Laplace transform. Second one, factorization you have to do x of s equal to 3s square plus 8s plus 6 divided by s plus 2 s square plus 2s plus 1. Find the inverse Laplace transform. Find the inverse Laplace transform. That is the questions. So what do you do? Factorize the denominator first. How will you factorize this denominator? 3s square plus 8s plus 6 divided by s plus 2 s square plus 2s plus 1. So how can you write this? A plus b whole square formula. A square plus b square plus 2ab. So can we write s plus 1 whole square? S square plus 1 square plus 2ab 2s. Okay. So if you do the factorize, you will get s plus 1 whole square. So already I told you how to do this factorization in Fourier transform, inverse Fourier transform. We have done it. S plus 2 simple pool, only one order is 1, but s plus 1 order 2. So what do you have to do? A divided by s plus 2 plus b divided by s plus 1 plus c divided by s plus 1 whole square. If cube is there, then d divided by s plus 1 cube. Okay. Suppose ax square plus bx plus c is there, then how to factorize bs plus c? One problem I'll give you how to solve those kind of problems. This is the factorization method. Then you cross multiply. So I'm not going to solve this completely. It will take a lot of time. Please practice. Similar problem are there already in Fourier transform. So many people solve in different method, but this one is very simple. Once you do the factorization, the left side numerator term you keep as it is. Denominator term you just multiply right side. So a into s plus 1 square plus b into s plus 2, 1 s plus 1 will be cancelled. Now c into s plus 2. Okay. So from this equation, you have to substitute s equal to minus 2. Then you will get a. S equal to minus 1. Then you will get c. Then compare coefficient of s square on both sides. Coefficient of s on both sides. And you find one more factor. Okay. So if you do it, you will get the final value x of s equal to 2 divided by s plus 2 plus 1 divided by s plus 1 plus 1 divided by s plus 1 whole square. Okay. I hope you can solve it easily. Please do it yourself, practice. Factorization, I'll tell you how to do it. Find a value, b value, c value from the equation number 1. By substituting appropriate s value or by comparing s square value on both sides, s value on both sides, you will get a, b, c value. Now our objective is for the given x of s should be factorized or splitted into formula. So what are the formulas we needed here? 1 divided by s plus a. E power minus at u of t. If we find Laplace transform 1 divided by s plus a. T e power minus at dot u of t. Laplace transform 1 divided by s plus a whole square. So these two formula we are going to use here. So inverse Laplace transform x of t equal to 2 constant e power minus 2t dot u of t plus 1 constant e power minus t dot u of t plus 1 divided by s plus a whole square. So t e power minus t minus a t, a value 1 into u of t. So this is my result. Inverse Laplace transform for the given equation. Okay. So any x of s given, partial fraction is very important for inverse Laplace transform. So far we are not concentrating regarding the ROC condition. because in the example nothing is mentioned. In the next class, I'll tell you for the given ROC condition how to write the result. Third problem, 2s plus 1 divided by s plus 1 s square plus 2s plus 2. Because I'm solving one model problem. First problem, simple poles. Second problem, pole repeated in the order of 2. Then how to do the factorization, right? Third one, ax square bx plus c formula. S plus 1 term is there. S square plus 2s plus 2. Then how to do the factorization? S square plus 2s plus 2. You cannot write a s plus 1 whole square, correct? So whenever in the denominator you are getting ax square plus bx plus c, which is not able to factorize. Suppose multiplication of two number must be 2, but addition of two number must be 2. There is no such factors available. So how to do the partial fraction, this kind of problem? A divided by s plus 1 plus bs plus c divided by s square plus 2s plus 2. Please remember this. This is the third method. I think only 3 methods are available in the partial fractional method. Simple pole, one pole, multiple order, and next ax square plus bx plus c in the denominator. Okay. In this way, you have to solve it. Now 2s plus 1. Keep your 2s plus 1 left side, this term, and multiply this entire term right side. So you will get a s square plus 2s plus 2. S plus 1 cancel. Next, bs plus c, this entire term multiplied with this term cancel, they will get s plus 1. Okay. After this simple procedure, you have to expand this in terms of s square, in terms of s, in terms of constant. Then only you can apply the value or compare the coefficient. 2s plus 1. Multiply this term b s square plus b plus cs plus c, and then what I suggesting, you s square separate term, s separate term, and constant separate term. So once you simplify this, take s square outside, you will get a plus b. Factor for s, 2a plus b plus c, and constant term separate. Okay. S square, a is there, b s square. So if we take s square outside, a plus b. So I wanted to know what is the coefficient of s square, coefficient of s, and what are the constant available in the right hand side equation. Okay. For this kind of problem, there is no other option. You have to solve in this way only. So s square, s constant term separately written. Now compare s square on both sides. Compare s square on both sides. There is no term s square left side. 0 equal to a plus b. Compare s on both sides. Here value 2. So 2a plus b plus c. And compare constant on both sides. Constant is 1 here. And right side 2a plus c. Okay. Now 3 equations are available. If you want to, you can solve it directly in the calculator. You can find the ABC value easily. Or add and subtract within these 3 equations. Equation 2, equation 3, equation 4. And solve it. You will get the values. I think a equal to -1, b equal to 1, c equal to 3. A minus 1, B1, C equal to 3. Directly you do the calculator to save the time, or solve these three equations and find out your answer. Right. Now rewrite your x of s again. X of s equal to minus 1, s plus 1. Next, bs plus 3, b value 1. So s, bs plus c. So s plus 3 divided by s square plus 2s plus 2. Okay. How we factor is bs plus c. So b value 1, c value 3. So s plus 3. Now 1 divided by s plus a formula available. But for this term, still we don't have this kind of formula. Okay. So we have formula for s plus a divided by s plus a whole square plus b square. If you find the inverse Laplace transform, result is e power minus at cos bt. S plus a divided by s plus a square plus b square. Sorry, b divided by s plus a whole square plus b square. We find the inverse Laplace transform of, result is e power minus at sin bt. Only these two formula available. So second equation we have to modify slightly. Second equation we have to modify slightly to get any one of this formula. Otherwise, inverse Laplace transform unable to find. So minus 1 divided by s plus 1. 1 divided by s plus a formula, no issue. Shall we write this term s plus 2 and plus 1? 2 plus 1, 3, no? S square plus 2s plus 2. Then s plus a divided by s plus a square plus b square. So minus 1 divided by s plus 1. S plus 1 divided by this term also we should rewrite actually. S square plus 2s plus 2. This particular term also we should rewrite in the form of a plus b whole square. Wait for another 5 minutes. We will complete this problem first. So what I am doing, minus 1 divided by s plus 1 plus s plus 3 divided by this particular term. I am rewriting s plus 1 square plus 1. Okay. S plus 1 whole square plus 1. S square plus 2s plus 1 plus 1. Both are same, correct? S square plus 2s plus 2. Same answer. This here also. If we expand s plus 1 whole square and then plus 1, you will get this answer. Okay. Why we are doing like this? We have formula s plus a whole square plus b square in the denominator. Now s plus 3 written as s plus 2 plus 1. So what I am doing now, this s plus 1, s plus 1, s plus 1 square plus 1. Assume 1 square. 1 square and 1 1. So s plus 1 divided by s plus 1 square plus 1 square plus 2 divided by s plus 1 square plus 1 square. Now we got the answer, but in the proper format, s plus a. Here is a constant, b value 1. So find inverse Laplace transform. Minus 1 is a constant, e power minus t u of t, plus s plus a divided by s plus a whole square plus b square. Your inverse Laplace transform, e power minus at, e power minus at cos bt u of t. A value 1, b value 1. 2 is a constant here. 2 is a constant. 1 divided by s plus 1 square plus 1 square. B value 1. So formula e power minus at sin bt. E power minus t sin t u of t. So this is your result. So there are 3 types of partial fraction. I had given example in each cases. Simple poles, how to solve it. Pole in the order of more than 1, how to solve it. Or ax square plus bx plus c, how to do it. And convert your formula, convert your answer in availability of the Laplace formula. And read it carefully, find the inverse Laplace transform and get it.